Okay, guys, this is what we talked about today during class, or what we started to introduce anyways, the patterns in linear functions. Just a reminder of your homework, it's this video. Good job. Way to be responsible and get this done. The vocab foldable, the yellow one, top 3 on each side, so 6, stop at domain and range, and the vocab worksheet. And on the worksheet, you just need to write the word that goes with each picture. Okay, so patterns and linear functions are talking about relationships, which we've been talking about with the graphs the last couple days anyways. In a relationship between variables, the dependent variable changes in response to the independent variable. So the dependent is which letter? Something depends on something else. Dependent is y, independent is x. So we need to remember y depends on x. That's very important. Input is the independent. So again, input is x. What we put into the machine gives us y. So if I have an equation and I put x in, my answer should give me the y. The relationships can be written multiple ways, one of which is by a table, one's with a graph, an equation, and in words. Then you're going to figure out if they're linear or not, and we'll see how to do that. So here's an example. Representing a linear function. The table shows the relationship between the number of photos you take and the amount of memory in megabytes left on your camera's memory chip. Is the relationship linear? So we're going to figure out if it's linear, and I'm going to show you how to do that. If it changes the same amount each time, it's linear. So looking at the table on the right, let's talk about what the pattern is. On this side, from 0 to 1, it increases by 1. From 1 to 2, again, increases by 1. 2 to 3, again, increases by 1. So see, those are all the same. On this side, what's happening from 512 to 509? If you put it in your calculator, or if you can do it in your head, it's minus 3. From 509 to 506, it's minus 3. And from 506 to 503, it's minus 3. So, if we notice in the table, at the 0, it's 512. That's going to be our constant when we're writing an equation. And just to review, in case you forgot, our equation is y equals mx plus b. And our constant, meaning b, is going to be our y-intercept, or where the graph is going to start in this case. So if that's our 512, we know that the memory card is going to have 512, and then it's going to be subtracted by a certain amount for every picture. So we're going to assume, or not assume, it shows you right here, that each picture is going to take up 3 megabytes. So in our words, we're going to say the memory card starts with 512, and we subtract 3 MB for each picture. So think about how you would write that in equation in a y equals mx plus b form equation, and tell me what that equation would be off to the side. Okay, good. You should have had the equation. The equation is y equals 512 minus 3x, but I like it in y equals mx plus b form. Y equals negative 3x plus 512. And it's negative 3x because I'm taking away from the memory every time. Okay? Now, we're going to graph this. This is our x, this is our y. So label them. This is going to be number of photos. This is going to be memory. Remember what I told you? If you're missing part of the graph, you draw that little zigzag. I kind of messed up. And then you can start where you need to. So I'm going to start with 500. I'm going to count by twos. I think I can get to 512, and that's good enough, right? 1, 2, 3, 4, 5 is good. Okay, so now I'm going to graph this. My first point is 0. Start at 0. Go up to 512. Then 1, go up to 509 between 508 and 510. 2, go up to 506. 3, go up to 503. Okay, and I want you to tell me what kind of line is this? What's happening? Okay, what we're going to do now is figure out if this one's linear, and if it is, we're going to write an equation for it. So, first thing, find the difference between, or figure out what's happening in the pattern. Over here, again, +1. Again, +1. Make sure it's for all of them. +1. What's happening on this side? That's +3. 8, 9, 10, 11, that's +3. 11 to 14, that's +3. So yes, linear, we know that much so far. Now, if I have a 0 for the x, remember that means this is my y intercept, so that's going to be my b. And my change is going to be 3. So I'm going to do y equals 3x plus 5. That's my first guess, and then I'm just going to check if it works. So then I'm going to put my input in, which my first input 0. 3 times 0 is 0, plus 5 is 5. That one checked. Then try the next one. 3 times 1 plus 5. 3 times 1 is 3, plus 5 is 8. That one checked. 3 times 2 plus 5. 6 plus 11. That one checked. And then the next one. 3 times 3 plus 5 equals 14. 9 plus 5, 14. That's correct. So yes, indeed, this is my equation. Good. So now, yes, it's linear. That's my equation. Your turn. I want to know two things. Is it linear? And if so, what's my equation? Make sure you double check yourself. Okay, don't forget your other homework. Good job, guys.